Hello friends, Mr. Burrell here. We just finished talking about evaluating trig functions using the unit circle. So if I gave you an angle and a trig function like sine of 30 degrees or cosine of pi sixths or a tangent of 7 pi sixths, something like that, you could use the unit circle to find those trig values. Sine, cosine, and tangent we can find using the unit circle because the x-coordinate is the cosine value, the y-coordinate is the sine value, and tangent is y divided by x, or sine divided by cosine. Now, this lesson, and this is the last one we're going to cover in this unit, we're going to talk about solving trig equations for angles. So what if I give you the coordinates on the unit circle, or I give you the trig function values, and I need you to find the angle? How would I do that using the unit circle? So that's what we're going to discuss. By the end of this video, by the end of this lesson, I hope that you're able to isolate the trig function on one side of an equation, and then solve trig equations using the unit circle. So again, we're using the unit circle. We're kind of going backwards from what we've already done. So, kind of reflecting back into our right triangle trigonometry knowledge, in solving a trigonometric equation for an angle, in the past, inverse trigonometric functions must be used. These are as follows. So like if I had 1/2 is equal to the sine of 30 degrees or something like that. Then in order to find what the angle was, if I didn't know what the angle was, I would use the inverse sine of 1/2 in order to figure out what that angle was. So inverse sine, cosine, and tangent functions, those inverse values, undo sine. So instead of solving for a missing side, it would give us a missing angle. So that same principle kind of applies here. We're going backwards. If we're given the side length, or if we're given the coordinates, if we're given the function value, we're going to go backwards. We're going to invert that, use the inverse functions, and find out what the angles are. So, instead of needing our calculator to do this, using the unit circles for these commonly used function values and these commonly used angles, we can use the unit circle to find the angle measures for corresponding trigonometric function values. So here are some tips, and I'll walk through each of these tips as we're solving these different types of problems. So first, isolate the trigonometric function so that it is the only term on one side of the equation. So for example, if I have sine, cosine, or tangent of an angle, I need to have that by itself before I can do anything else. I can't have like a 1/2 here, or I can't have it being added by 6. I need to have the sine value all the way by itself, being equal to whatever numbers over here, in order that I can use my inverse trig functions in order to solve for the angle. So we're going to isolate the trigonometric function so that it is the only term on one side of the equation. Then, using the unit circle, we'll find the value remaining in the coordinates of the circle. So say I have sine of theta equals 1/2. Whoops, 1/2. Well, I'm going to find 1/2 in the coordinates on the outside of the unit circle because I know 1/2 is going to be one of the trig function values. And then the angle associated with those coordinates is the answer in degrees or radians, depending on what you're asked for. So on my unit circle, if I look for 1/2, I'm going to find an angle associated with the sine value that's 1/2. So let me, before we go into these questions right here, if I were to look on here, on my unit circle, where sine is equal to 1/2, or where y is equal to 1/2, I'm going to find that right here. There's a y value that's 1/2, but I'm also going to find that right here. So in both of these places, where the angle is 30 degrees and 150 degrees, in those two places, I will have my angle measures that correspond with my sine value. So if the sine of this angle is 1/2, theta is going to be 30 degrees or 150 degrees. Every one of these problems that you do in this assignment will have two answers. Almost every single one of these will have two answers. And I'll kind of walk through why that's the case on this next slide. Okay. Oh, look, there it is. Remember, for each trig function value, there will be two possible angles that will work as solutions. because I have these coordinates right here, right, that are reflected into every single one of these other quadrants, notice that here, the x and y are both positive, so tangent will be positive. Here, x is negative, y is positive, so cosine is negative, sine is positive, and therefore tangent will be negative. Here, my sine and my cosine values are both negative, so my tangent will be positive. And here, my cosine values are positive, my sine values are negative, so therefore my tangent values will be negative. A way that I kind of remember where each of these values are, I always remember, and this applies to you too, that all students take calculus. So in this quadrant, all of the function values are going to be positive, sine, cosine, and tangent. And in the second quadrant, the sine values will be positive. In this quadrant, the tangent values will be positive because a negative divided by a negative is a positive. In this quadrant, the cosine values will be positive. All students take calculus. That's kind of a handy mnemonic that I sometimes use to help me remember where the trig function values are positive or negative. I'll leave that up here. All students take calculus. But the big important thing to remember is that with every function value that I give you, there's going to be two possible angle answers. This is another reason why you can't necessarily use your calculator for these responses, because your calculator will only give you one possibility, where in fact, in the unit circle, there will be two possible solutions. Okay, real quickly, this is going to be handy for us as we go throughout these problems. We're going to find the tangent values for these functions in the first quadrant. So tangent of 30 degrees is y over x, or, this is swapped. These ones need to be swapped. This is tangent, of 60 degrees. This is tangent of 30 degrees. So the tangent of 60 degrees here is y over x, or square root of 3 over 2 divided by 1/2, which is equal to, when I multiply by the reciprocal, square root of 3 over 2 times 2, which is equal to the square root of 3. So my tangent values, I'm going to write my tangent values over here in red. My tangent value for here is going to be the square root of 3. Tangent of 45, this one's really handy because since y and x are the same, when I divide them, I get 1. So the tangent of 45 degrees is 1. Then I have the tangent of 30 degrees. Tangent, again, is y over x, or 1/2 divided by the square root of 3 over 2, which is 1/2 times by 2 over the square root of 3 when I multiply it by the reciprocal, which is 1 over the square root of 3, or when I rationalize the denominator so there's not a square root, I get the square root of 3 over 3. Square root of 3 over 3. So those are going to be really, really handy when we're talking about these different values in the unit circle. So here, this is going to be the square root of 3 over 3, 1, and the square root of 3. This is going to be negative square root of 3 over 3, negative 1, and negative square root of 3. And this is going to be negative square root of 3 over 3, 1, and square root of 3. Notice, all students take calculus. Tangent values are positive in the first quadrant and in the third quadrant. So you might want to write those values on your unit circle. You don't have to. You might just want to remember them, but I think it would be helpful to write those values on your unit circle so you know the tangent values associated with some of these different angles. Okay, let's walk through some examples of types of problems you might see here. So, first couple of questions. This says solve each equation for, and this says 0 less than or equal to the angle theta less than or equal to or less than 360. That says find the angle answers for this question between 0 and 360 degrees. So our answer is going to be in degrees. That's what that means. So sine of theta is equal to 1. So what I'm looking for, sine, again, if I'm looking at my x and y coordinates, cosine of theta is the x coordinate, and sine of theta is the y coordinate. So I'm looking for where on this unit circle do I have a y coordinate of 1? Well, here I have a y coordinate of 1. Here I have a y coordinate of negative 1, so that's not going to work. So this actually is my only angle, theta equals 90 degrees. And I bring this example up right at the beginning. On these for these four axes, the x-axis and the y-axis here, these four angles, those are some special cases. So sometimes on these special cases at 90, 180, 270, and 0 or 360 degrees, there will be only one answer. Most, like 90% of the time, there will be two possible angles. In this case, there is only one. So the sine of theta is equal to 1. That means the angle where the sine is 1 is 90 degrees. Okay, so that's my answer. There's only one there. Here I have 3 multiplied by the tangent of theta equals negative 3 square root of 3. So, remember that in the tips that I gave you earlier, before I can deal with my tangent, I need this tangent all by itself. I need to isolate the trigonometric expression by itself, get everything else to the other side. So here I have 3 times the tangent of theta. So I'm going to go ahead and divide by 3 on both sides, because that means these 3's will cancel, and I'll be left with tangent of theta equals, these 3 cancel, negative square root of 3. Okay, well, if you remember, if we go back here, square root of 3, oh, these were supposed to be negative, I apologize. Square root of 3 as the tangent value is going to show up at each of these spots right here. So where tangent is negative square root of 3, tangent is going to be negative in the second and the fourth quadrant, as you see here. And again, I'm reflecting back to this unit circle. You don't have to do that if you have them written down. But here I have tangent being the square root of negative, or the negative square root of 3. And here I have tangent negative square root of 3. So notice how they're directly across from each other. So my two angles, for which the tangent of those angles would be negative square root of 3, are 120 degrees and 300 degrees. So theta is equal to 120 degrees or 300 degrees. Those are my two possible solutions for which the tangent of those angles would be negative square root of 3. Okay, so again, what I'm doing is I'm solving for the tangent, getting the tangent by itself, finding the trigonometric value on the unit circle. In this case, it was the tangent, so we had to go that extra step and find the tangents ourselves. And then find the angles associated with those trig functions. Okay, here's a couple of the problems on your homework that I wanted to go over. It says solve each equation for an angle between 0 and 360 degrees. So that just means I want your answer to be in degrees. Okay, so this is homework number 7 on your homework. It says negative 3 times the square root of 3 equals negative 6 times the cosine of theta. So I need to get this cosine by itself before I do anything. So I'm going to go ahead and divide by negative 6 on both sides. Oops. So that means this will cancel, and I'll be left with cosine of theta equals, I'm going to reduce this fraction, negative 3 divided by negative 6. My negatives cancel. 3/6 reduces to 1/2. So cosine of theta is equal to the square root of 3 over 2. Okay, well, the coordinates on my unit circle match up with the sine and cosine values. So I'm looking for, on the outside here, a cosine value that's the square root of 3 over 2. A positive square root of 3 over 2. Okay, well, cosine values are the x-coordinates, so I'm going to look for the x-coordinates where I have the square root of 3 over 2. Here's a negative square root of 3 over 2, negative square root of 3 over 2. Here's a positive square root of 3 over 2. So the angles for which the cosine of those angles is the square root of 3 over 2, those angles are 30 degrees and 330 degrees. 30 degrees and 330 degrees. Those are my solutions. Okay, let's do another one. This next one is homework problem number 10. I have negative 4 plus 2 times the sine of theta equals negative 6. So I'm going to kind of do reverse order of operations here to undo all this. I'm going to go ahead and add 4 on both sides because I'm wanting to get the sine by itself. So I'll have 2 times the sine of theta equals negative 6 plus 4 is negative 2. And then I'm going to go ahead and divide by 2 on both sides. And I'm going to get sine of theta equals negative 2 divided by 2 is negative 1. Okay, well, on my circle here, I'm trying to find where the sine is negative 1, or where do I have 1 in the y coordinate? Well, right here I have a 1 in the y coordinate, and that's it. So theta is equal to 90 degrees, because when this angle is 90 degrees, the sine of that angle is, oh, hello, backtrack, I apologize. This was sine is equal to negative 1. The only place where I have sine being negative 1 is down here at 270 degrees. I apologize, I was looking at positive 1. The only angle where the sine is equal to negative 1 is the angle of 270 degrees. Remember, on each of these 4 angles right here, we have some pretty special cases, and often we'll only have one angle. Negative 270 degrees. Sorry, 270 degrees. Okay, so we've done some examples where we're looking for angles in degrees. Let's look at some examples where I'm looking for angles in radians. So now I'm doing the exact same thing, but instead of giving my answer in angle measures, I'm going to give my answer in radian measures. Okay, so cosine of theta is equal to square root of 2 over 2. Cosine here is already by itself, so what I'm going to do is I'm going to find, remember that my cosine values match up with my x coordinate. So I'm going to find on this unit circle, where is my x coordinate? Square root of 2 over 2. Okay, well here I have my x coordinate being the square root of 2 over 2. This is a negative square root of 2 over 2. Negative square root of 2 over 2. Here's a positive square root of 2 over 2. And that makes sense because since all students take calculus, I figured that my cosine value would be positive in the first and third quadrant because all of them are positive here and cosine is positive here. So what's the angles here that match up with the cosine value being the square root of 2 over 2? Well, my angles are 45 degrees and 315 degrees. Those are my two angles that if I were to take the cosine of those angles, I would get positive square root of 2 over 2. Okay, here I have negative 3 times the sine of theta equals negative 3. So I need to get the sine function by itself. So I'm going to divide by negative 3 on both sides. I'm going to get sine of theta equals 1. Wow, I ended up picking a lot of these. I don't know why. Well, where are my sine values, or where do I have a y coordinate that's 1? Well, right here. And that's it. So my angle theta is equal to 90 degrees. Do you notice anything that I did wrong on this page here? Shoot! My instructions told me to find an angle between 0 and 2 pi radians. My angles needed to be in radians. So instead of on this problem writing 45 degrees and 315 degrees, I would need to write pi fourths and 7 pi fourths. Same angles, just written in radians. So pay attention on your homework assignment. It will give you criteria. It'll say either between 0 and 360 degrees or between 0 and 2 pi. I want you to find the angle measures in radians or degrees depending on what you're asked. So then this one, with my angle being 90 degrees, when I came up here, instead of writing 90 degrees, I'm going to go ahead and write pi halves because I want it in radians. So again, I'm finding the coordinates for these sine values on the unit circle and finding the corresponding angles that match. Okay, so these next ones, this is homework problem number 17 on your homework and number 19 on your homework. So I have negative 4 times the cosine of theta equals 2 square root of 2. So to get cosine by itself, I'm going to go ahead and divide by negative 4. Those will cancel out, and I'll be left with cosine of theta equals 2 divided by negative 4. That's going to be a negative 1/2. So negative square root of 2 over 2. So what I'm looking for where on my unit circle do I have a cosine value or an x value of negative square root of 2 over 2. Well, these are all positive cosine values. Here's negative cosine values. Here's some more negative cosine values. There's a negative square root of 2 over 2, which makes sense since all students take calculus. I only expected cosine to be positive in the first and fourth quadrants, so they are negative right here. So the cosine values of these angles right here give me negative square root of 2 over 2. Well, what are those main angle measures in radians? 3 pi fourths and 5 pi fourths. My angle measures there are 3 pi fourths and 5 pi fourths. So the cosine of 3 pi fourths is negative square root of 2 over 2, and the cosine of 5 pi fourths is negative square root of 2 over 2. Okay, awesome. Next, I have tangent of theta, or 3 minus 1/3 times the tangent of theta equals 10/3. So this one is, again, number 19 on your homework. I'm doing this one together because it's kind of beautiful. So first I need to go ahead and subtract 3 on both sides because I need to get rid of this 3, and then I'll take care of this 1/3. So I'm left with negative 1/3 times the tangent of theta equals 10/3 minus 3. What's 10/3 minus 3? You could do that in your calculator and change it to a fraction, or you could write 3 as 9/3 if you got a common denominator there. 10/3 minus 9/3 is 1/3. Okay, well, negative 1/3 times tangent of theta is equal to positive 1/3. All right, well, if I multiply both sides here by negative 3, negative 3 times negative 1/3, those will cancel out, and I'll just be left with tangent of theta. Now on this side, if I multiply by negative 3, 1/3 times negative 3 is just negative 1. Okay, so I'm trying to find where my tangent values are negative 1. So I'm going to go back here just a minute. Where are my tangent values negative 1? Well, they're negative 1 right here and right here. So let me go back over here. Oops. My tangent values were negative 1 right here and right here. Because you notice that my sine and cosine values are the same, so when I divide them, I'll get either 1 or negative 1. And since all students take calculus, I know my tangent values are only going to be positive in my first and third quadrants, so in my second and fourth quadrants, they're going to be negative. So, right here and right here is where my tangent value is equal to negative 1. What angles do I have there? Well, I have 3 pi fourths, and I have 7 pi fourths. So my angle values where the tangent would be negative 1 is at 3 pi fourths and 7 pi fourths. And again, I wrote those in radians because that's what I was asked to do in the instructions there. Okay, that is all I've got for you. Again, that's the last lesson we're going to cover in this unit. You have a couple days to do this and to make up some other things that you might be missing. So hopefully by the end of this video, you're able to isolate trig functions, isolate sine, cosine, or tangent on one side of the equation, get it completely by itself, and then once you've isolated the trig function, hopefully you're able to solve trig equations using the unit circle. Again, by finding those function values in the coordinates or in the tangent values associated with the unit circle and finding the corresponding angles that would give you those trig functions. So I hope that was helpful. Please, please, please don't hesitate to reach out and ask me any questions that you might have. Any questions whatsoever, and I hope that you enjoyed that as much as I did.